Hello everyone, I'm Yogesh Panchal and we are learning engineering graphics and design. Our today's topic is orthographic projections from chapter orthographic projections and sectional orthographic projections. Today we will see problems of orthographic projections, how to convert 3D drawing into 2D projections. So we are taking one problem, draw front view from X directions, top view and left hand side view for the given figure using first angle projection method. So we have one 3D pictorial view with dimensions and one arrow is given. Now this arrow represents the position for observer, and from this position when the observer observes, that view is known as always front. So in 3D object, which is a combination of number of points, lines and planes. So in earlier chapters, we already discussed the orthographic projection of point, line and planes and also solid. So here we have to just take the projection of all points, all lines, all planes in the reference plane. We have to draw three views: front view, top view and left hand side view using first angle projection method. So we must know the position for the 2D projections. Front view is always above XY line in first angle, top view below XY line, and side view means left hand side view placed on right of the front. Now first of all we have to observe the object and find out the overall length, width and height of the object. So here from this point to this point, overall length 30 plus 30 plus 20, so 80 mm length. What is width? So this line represents for width, so 15 plus 20 plus 50, so 30 plus 20 means 50 mm is width. And height, so height is the distance between bottom horizontal plane and top horizontal plane. So this distance is obtained from here, 35 plus 10 is 45. So our first task is find out the overall length, width and height. Now because we are using first angle projection method, front view, top view and left hand side view, positions of the views. Then start your drawing 2D projections. First you have to draw an XY line, then x1 y1 from any point which is perpendicular to xy. Now front view is one rectangle in which the size of the rectangle is length and height. Top view in which it will come in the one rectangle of length and width, and side view width and height. So first of all you have to draw the overall length and height. Draw one rectangle means our front view come in this rectangle only. Similarly top view come in this rectangle which is of length and width. And for side view, by taking 45-degree inclined line, take horizontal line from top view and take horizontal line from top view up to 45 degrees, then vertical and horizontal from front view. So this is the border line of front to top view and left hand side. Now start your drawing by observing First we have to draw front view. So assume the observer is here and he looked the object in such a way that the iris is always perpendicular to vertical plane. So here somewhere vertical plane is there on which the projection will obtain. This is position for front. Now first you have to draw the bottom plane which is parallel to HP, okay, or base. So because the horizontal plane and bottom plane both are parallel, the front view on vertical plane is line. So this is a front view of base of the object. Now from right side plane, okay, for this line vertical, this is horizontal line parallel to base. So front view like this. This is vertical line up to this surface. Now draw horizontal line. Actually, this line is front view for this whole surface because when the plane or the surface is parallel to HP and perpendicular to VP, the front view is line. This is also a plane for this plane. This is front view for this plane, this and this. This is front view for this plane. Now front view for this plane, because this plane is inclined to HP and perpendicular to VP. So front view is inclined. Now what about this line? This is inclined to HP and inclined to VP and parallel to profile plane. So this is the front view of that line. Now for top, once you draw the front view, you will get the 50% help for top view by taking the vertical projection line from every corners. This dimension represents width, it's 50 mm. Now you can start your top view from this corner. So when you're looking from top, the top view of this line is this. What is the top view of this line? Top view of this line. Top view of this surface or this line. This line is actually perpendicular to HP. So the top view of this line is only point. The top view of this plane, vertical line. Now this is one semicircular slot. So when you observe from top, you will get the true shape of the semicircles. This is the center for the semicircle. So this is center and you have to take 15 mm radius and draw one semicircle. This line is, and this horizontal line represents the top view of the back plane, which is parallel to this plane. Draw horizontal line, which is the top view of this plane also. This line. Now, for this particular plane, when you observe from top, you will get the horizontal line. For this plane, vertical line. Here one plane is also which is parallel to this plane. And this is the top view of this line and top view for this plane. Now this surface is inclined to HP. So when you observe from top, you will get rectangle but not true shape. This is the top view for this particular surface. Now here one plane which is inclined to HP as well as inclined to VP. So for this top view, this is rectangle. Now this hidden line represents the front view of this surface, because when we observe from here the surface is hidden. So the hidden surface is represented by a dashed line. The top view of that surface is here. Okay. So another, which line or which surface is hidden? The semicircle you cannot see from front view. So the end of radius means here this surface represented by hidden line, and from front view this surface is also here. Now how to draw side view? So once you draw front view and top view, the 50% help from front view and 50% help from top view by taking horizontal projection line from top view and then vertical and then horizontal from front view. So you have to draw all the lines from all the corners. Now this is the position for observe for left hand side view. First of all you have to draw left hand side view of this rectangle here. This is 15 mm and height 20, so 50 by 20, then again 15 by 20. And for this left hand side view is this. For this plane, side view is vertical and this is also vertical. Now this is total distance 50 mm width and this is semicircle diameter 30 mm. So this dimension is 10 mm and this is also 10 mm. So that 10 mm dimensions come from here using projection line. Left hand side view of this particular rectangle and also for this. Now from left hand side view this top surface looks horizontal line. It looks like this. And for this inclined or tapered surface from left hand side view, because this plane is perpendicular to profile plane, the projection on profile plane will be line, and that line is hidden, drawn from this point to this point, which is 10 mm. So insert all the dimensions using a line system: 30 mm, 30 mm, 20 mm, 20, 15, 15, semicircle 15 radius. So insert all the dimensions which is required. So front view, top view and left hand side. Next problem. Draw front view from X direction, top view and left hand side view for the given figure using first angle projection method. So this object in which length 60 mm, width 60 mm and height 40 mm. There is one slot here. This is a tapered surface or inclined surface. One part is also removed from here. This surface is perpendicular to HP, perpendicular to VP and parallel to profile plane. This surface is inclined to HP, inclined to VP and inclined to PP also. This triangle is perpendicular to HP, inclined to VP, inclined to PP. So find out overall length 60, width 60 and height 40 mm. Because we are using first angle, we have to draw front view, top view and left hand side view. This is positions front view, top view and left hand side view. First of all, you have to draw one XY line and X1, Y1. Draw three rectangles for front view, top view and left hand side. So front view, length and height. Top view, length by width. And left hand side view, width by height. Start your drawing from bottom of the object, which is a plane surface, 60 mm. This is position for front view. When we observe the front view, start bottom plane, base, horizontal line of length 60 mm, then vertical line 40 mm, then draw 20 mm horizontal line, then vertical line 10 mm here because there is no material here. This is 15 mm horizontal line, vertical line again 10 mm. Then you have to move like this 10 mm, vertical line 20 mm, and you have to join this corner with inclined line. This is front view without hidden lines. And this line is also full line because when we observe from here, this surface from here to here, there is one horizontal line. Now, if we observe this surface for this slot, it starts from here. This is front view for this line, and the surface goes up to this end. So this surface goes up to this line, which is, you know, how many mm below? 10 mm below. So it visible up to this line, and then it is hidden. Now this point, which is 20 mm above. Now this point is 20 mm from base, and this point is also 20 mm from base. Means this line is parallel to HP. So its front view is horizontal line, and for this line start from here and end at 20 mm above base. So it start from here and above 20 mm from base. So it is front. So this triangle is front view for this surface, and this triangle is front view for this surface. Now what about this surface? It start from here, start from here. This point is this, and end is 20 mm below top or 20 mm above HP here. So this hidden line represents the front view of this slant surface. What about top view? By taking vertical projection lines. Now top view, start the top view from this line, this corner to this corner. This is front view and top view for this corner, and for this corner this is front view and this is top. So this straight line represents here. Also, if you left 8 mm here and 10 mm here, so 10 mm this and 8 mm from here, draw one line. This is top view of this line, top view of this line. Join this surface or this line, top view for this particular rectangle, top view for this surface, top view for this triangle because it is perpendicular to HP and perpendicular to VP, top view vertical line. Now for this line, top view is here, and the surface is perpendicular to HP for this line and this line. Both are in same plane which is perpendicular to HP. So this line represents the top view of this, both the lines means this surface. Top view for back surface. Okay. So almost top view is ready. Now for side view, we are using 45-degree. Take horizontal projection line from every corner from top view, then vertical line, and the horizontal line from front. So you are using left hand side view. So this is position for left hand side view. So draw horizontal line, a vertical line for this, and draw this triangle, vertical line for this line, then horizontal line represents this, vertical line for this. Now inclined line from 20 mm above, and this line represents here. This is horizontal line from this surface because which is parallel to HP and perpendicular to VP, perpendicular to profile. So front view is line, This is front view from back surface. Now what about this surface? Because from left hand side view you cannot see this surface. So for side view of this surface, it start from here. It start from here, which is 10 mm below. It goes up to this point as well as this point. So distance between these two points is 22 mm, left 8 mm from left side. So from here this is 8 mm, and also you can find from here also. So this two hidden line represents the side view of this edge or line here and here also. And side view for this line is hidden, and it is moves up to this particular line. So you have to draw one hidden line up to this vertical line. Insert all the dimensions: 15, 10, 15, 20 mm, 60 mm width, height 20 mm and 20 mm, length 60 mm, and for side view 8 mm, 22 and 30 mm. And here 10 mm for slot and 40 mm height. Okay, thank you very much.